Hello everyone, Dave Russell here from the JTAC Local 787. In this video, I'll be demonstrating the Honeywell W7212 training board that we have available at our hall. This economizer uses 24 volts, so we have a step-down transformer from 120 down to 24 volts. We've sized this fused based on the VA rating of that transformer. Right now, this unit is unoccupied, it is turned off, so the dampers right now are fully closed. We're going to go ahead and turn on the unit. So right now we have the indoor blower motor turned on. The dampers will go to minimum position. I believe the minimum position pot right now is set to 0, so we have the dampers still closed. Now we're going to go ahead and ask for stage 1. We got stage 1 on right now. The free cool light is turned on, so we're in free cooling mode. Those dampers are now going to start modulating to maintain the set point of the mixed air temperature sensor. This set point can be changed either by adding resistors in series or parallel. So right now with this unit has no resistors, so I want you to look up and tell me what set point this economizer is trying to maintain. So if I go ahead and cool down that mixed air sensor, those dampers will begin to close. Right now they're still modulating open, but if we just go ahead and just cool them down a little bit here, you can hear the damper motors change and the dampers are closing. So let's just say we're not bringing enough outside air to satisfy the space. The thermostat will decide that you need to turn on second stage, which will bring on first stage mechanical cooling. So right now we have 2 stages of cooling on. First stage is the economizer, and second stage is first stage mechanical cooling. So we need to have a set point for when do we actually switch into economizer mode and when do we use both compressors. So in the logic module we have a set point, which is A, B, C, or D. So it gets its information via the outdoor air enthalpy or the return out enthalpy. They're sending their information via a 4 to 20 milliamp signal back over to the logic module, where it decides if it's suitable for free cooling or not suitable for free cooling. So right now we're reading 14.01, 14 random dot there, milliamps volts DC. So that represents enthalpy. So if you turn to page 13 in your book, you'll be able to see what enthalpy setting that actually is. So if I end up breaking a wire, so now I've just tricked the logic module. Now it reads 0 volts. Well, 0 volts actually reads something as well. So right now, I'm presuming it's going to be very hot outside because our dampers are going to go to minimum position. We have both stages kicked on. So I can tell you 0 millivolts is tricking this to think the outside air temperature is really hot. The only way to tell if the outdoor air enthalpy sensor is working is to put your meter in series and measure the milliamp reading and go to the chart and see if what you read is actually what you read with the thermometer is actually what you're reading with the enthalpy sensor. The mixed air temperature sensor can be checked by reading the ohm reading and going to the chart on page 12.